Hey everyone, welcome back to the last theoretical video of chapter 8, which is about volumes in enlargement still, but now we're going to take a look how we can go from volume to scale factor. But before I'm going to let you fully experience how that works, we first have to take a look at how cube roots work. And we know normal roots, we call them sometimes square roots, right? Normally we call them square roots. They are for taking a look at numbers like this. A square root of 25 is 5 because 5 squared is 25. Cube numbers correspond to cube roots. For example, 5 to the third is 125. Therefore, the cube root of 125 equals 5. The third of the cube root of 125 is 5. So the cube root of 125 is 5 because 5 to the third is 125. A few extra examples. The cube root of 8 is 2 because 2 times 2 times 2 is 8. The cube root of 27 is 3 because 3 to the third power is 27. The cube root of 1000 is 10 because 10 times 10 times 10, or you could say 10 to the third power is 1000. And for example, the cube root of 1 is still 1 because 1 times 1 times 1 is 1. Okay, so this is how cube roots work. Please do exercise 59 because that one introduces you to this stuff and lets you practice with this as well. Okay, then theory B. And there we need those cube roots. If a cylinder, for example here, has a volume of 33.75 cubed centimeter, then if I have another one here with a volume of 10 cubed centimeter, then the volume of cylinder B is divides the volume of the image by that of the object, and we get 3.375 times the volume. And then they just say therefore k to the third is that number. And they don't give you this formula, and I'd like to give you this formula again, just as I did with 8.4 theory B. Then I said k squared is area and image divided by volume of area and object. Now it is k to the third power, and I say that's the same as dividing the volume of the image by the volume of the object. How can I now get to k again? Well, k is going to be the cube root of that number. So here, this is 3.375. Then k is going to be the cube root of that number is 1.5. Okay, and they start again with the number p. If the volume of an enlargement is p times as large, the scale factor is cube p, cube root p. Okay, let's practice one. We have two tins of peanut butter, 2 jars. Jar B is an enlargement of A, so A is the object, B is the image. Calculate the scale factor. We don't know dimensions or area, but we do know volume, right? Volume can also be given in milliliters. So what's going to be the scale factor K? Well, I cannot in one go calculate K, but I can calculate K to the third power, because that is the volume in the image divided by the volume in the object, which is 500 divided by 300. Gives me 5 over 3. What is now k? Well, we said if I want to go from k to the third to k, we're taking the cube root of this number, right? So we take k is the cube root of 5.3. Is approximately 1.2. That is the scale factor. Remember, scale factor is always just k, not k squared or k to the third. That means every line gets 1.2 times as big. The volume, as we see, becomes 5 over 3 times as large. Okay? Now, if we know the area of the lid of A and we want the area of the lid in B, remember area works with k squared. We don't know k squared, but we do know k. How can I go from k to k squared? Yeah, by squaring this number, right? K squared times the original area. So they do. They take this number here instead of 1.2, and it should be a point here, right? That's just not how you notate in English mathematics. So, and furthermore, don't use this because this is an approximation. By using this, you're more exact. So you take the original number without rounding it, square it, right? Because K squared times what you start with, which gives me around 70.7 squared centimeter. Remember, now we're talking about area again. And I think the most difficult part of this last paragraph is you going back and forth between converting between k to the third and k squared, and when do I have to use which. So again, I will put on some videos which will try to explain this a bit more in depth, and I will also try to make a summary of 8.3, 4 and 5 and put this in some kind of table or some kind of summary, so it's nicer to understand and see how this works, because I think the book does a bad job giving you an overview of how this works with scale factor in dimensions, areas and volumes. So I will try to construct something that will give you a better summary for that. For now, good luck with practicing, and if you have any questions, feel free to ask.